All right. So good morning, everyone. Thank you so much for attending this webinar. All right. So we would like to welcome everyone to the audience. And we would also like to acknowledge the presence of our marketing coordinator. Here is Leah. Thank you so much for coming, and Riley. Okay. And of course, our presenter for today, Dr. Harisinh Parmar. All right. So just for everyone, for you to be able to have a laser focused attention on the topic today, yeah, we would like to request everyone. Just take control this. Okay. Okay. So yep, we would like to remind everyone to have your laser focused, again, laser focused attention. Please turn off all those notifications. So the instructions will be in your screens. And if you do have any questions, please save it up because we will having up a quick Q&A sessions at the end of this webinar. Okay. Hello. All right. So again, kindly turn off those notifications, and the instructions are on your screen for you to be able to have a laser focused attention on the presentation today. Any questions will be answered by our presenter at the end of the session. Okay. All right, so again, I would like to welcome everyone. This is our day 2 for our virtual open week 2024. And today's topic would be insights into EIT's remote and virtual laboratories. This will be presented to us by Dr. Harisinh Parmar. He is actually our EIT laboratory coordinator and manager. Okay. So for common questions and FAQs, a copy of the slides will be sent to your registered emails for those who have registered for this webinar. And please expect receiving that one on the 21st of October 2024, Monday. And also please monitor your junk mails as it usually goes straight there. So kindly check that out. All right. So a little bit more about EIT. So we are actually an education provider based in Perth, Western Australia. We also have our campus in Melbourne, and we recently opened our campus in Brisbane. So we are an engineering specialist. We're one of the institutions that specializes in engineering courses, and we deliver a wide range of programs. So from our non-accredited programs, which is professional certificates, and towards our accredited programs, our advanced diplomas, undergraduate certificates, bachelor's, graduate certificates, graduate diplomas, masters, up to Doctor of Engineering. These programs are actually industry-oriented programs, which are designed by industry experts themselves. All right, this is to actually to ensure that the graduates have cutting-edge skills and which are valuable to the employers as well. So we are working hand in hand with of course, potential employers to make sure that our teaching, the students' learnings are based on what is really needed in the industry. And of course, our programs, our vocational programs and higher education courses are accredited by the Australian government, as well as it is recognized. Some of our programs are recognized under the 3 international engineering accords, which is Sydney, Dublin, and Washington Accords. Okay, and of course, these programs are delivered by industry expert lecturers. Okay, so we make sure that you have the quality education that you'll be needing when you land your job. Okay, and then we make use of a unique delivery model, which is using of our interactive webinars such as this. We have international pool of expert lecturers, and at the same time dedicated learning support officers, and most of all, our state-of-the-art hands-on workshops, remote laboratories, and simulation softwares, which will be discussed to us further by Dr. Harisinh Parmar. All right. So, Doc, I'll hand over this to you. You can start your presentation. Thank you.
Thank you, Marvin, and very welcome all of you guys, those who are interested to see the remote laboratories and the remotely controlled and simulated laboratories of EIT. Let me take control and then I will go through the presentation. Can you see my slide moving?
Yes, Doc.
Okay. Okay, so let me start with the session agenda. So I will welcome everyone. So welcome everyone, and then I will introduce myself. I will talk about EIT. I think Marvin already talked about EIT, that how we developed our curriculum, how we present our curriculum, how we deliver using the remote labs. We are giving all our students a practical exposure, even though they are online students. So that is about EIT, and then I will talk more about the remote lab. That is the main session. So remote lab, I have the breakdown in three sections. So I will talk about how our remote labs, and then more on the remote lab or more on the physical side, I will talk about the hands-on workshops and work integrated learning. And then we will have, if you have any questions, we have Q&A session as well. So moving to the introduction, as Marvin mentioned, that I am the laboratory coordinator and manager here in EIT, joined EIT since 2019. Before that, basically, technically I'm a chemical engineer, studied in Curtin University, finished my doctorate, and then I joined EIT as a lab coordinator. Okay, so talking to you about the remote lab and how we are combining our expertise to a remote lab and a physical lab experience. So remote practical experience. If you think about the engineering education, you always think about the practical side, right? You always think about the um, how how you can keep yourself ready, make yourself ready for industry work. If you are studying online, that is the main question, that how I can get exposure of the hands-on experience, right? So that's where remote lab and virtual lab comes into the picture. So our students are basically completing different practical and hands-on exercise using
Dr.
our remote
Harrison.
lab. Mhm.
Dr. Harrison, let me just cut you off for a bit. I think we have an issue with the screen, so let's just
Okay.
check first. Yeah, because we have comments on the on the
I
chat
would
box that they can see.
I
Yeah.
would I would recommend that anyone currently in the session, if you're having issues seeing the slides, if you leave the session briefly and just rejoin, it seems to resolve that issue. I had the same issue myself. So
Mhm.
if you just leave the session just for a second and rejoin using the same link, it should you should see the slides again. Apologies for the inconvenience.
All right. Yep, and
Okay.
yeah.
Mhm. But basically, if I move the slides, everyone can see the slides are moving. Is that correct?
Yes, yep, all
Okay.
good,
Okay.
Yes,
Harrison.
yes.
All good.
All good.
All good. Okay. So moving forward on a remote and virtual lab. So basically, you can see on your screen that how we host our Electromeet server and local lab server. So on the Electromeet server, it's called electromeet.com, and that's where we host all our remote labs. Okay, and that is connected to internet. So we have a, let me just write, yeah. So we have a local server, and we have that hosted on Electromeet server connected to the internet, and any of our students around the world can join and access the remote lab. Okay, so that is providing a better exposure to the traditional lab at a distance, and it's in real time. Okay, you can see the accurate representation of the current industry hands-on practice. You can interact with equipment as well. And obviously, we have a booking system and high availability of the software. So you can book around the clock. You don't need to worry about booking in the office time. You can book around the clock. So the bookings are available. Software are available on multiple remote labs. Single software are available on multiple remote labs, and you can access those around the clock. We have a support system and testing environment available for students, and there is no geographical barrier, as I mentioned, that booking is available around the clock, and the bandwidth requires and can be demanding. So you need to be connected to the good speed of internet, and that's where our remote lab comes into the picture. That okay, you have in order to operate the remote lab, you have a good bandwidth of the internet. Okay, let me go through a simple process of connecting the remote lab through our learning management system. So our learning management system is Moodle. So if as a student, you can have a login to Moodle, you have access to Moodle. If you go on a Moodle website and click on site home, you will get the remote lab icon there, remote lab shortcut. Once you click on remote lab shortcut, you can see that access the remote lab or access the lab button. And that will guide you to the lab.electromeet.com platform. That's where we host all our remote lab. I'll show you how it look like. So this is where you will see that all the remote labs are available. We have somewhere around more than 30, 40 remote labs available. And we have multiple software related to all different disciplines of engineering, such as civil engineering software, mechanical engineering software, electrical and industrial automation engineering software is available on remote lab. Additionally, apart from the software, we have remotely controlled equipment available on our remote lab as well. I will give you a few examples further in this presentation, but these are the remote labs available on our Electromeet platform. Now, in order to book the remote lab, you need to click on the calendar icon and see whether the particular remote lab or particular software available on that remote lab is available for you to use at now or later stage. Okay, that is depends on how busy is our remote lab. But if let's say one remote lab is busy for one particular software, you can search the same software on another remote lab and book accordingly. Okay. So once you book the remote lab, you will see your time slot in green. And that means you have booked for particular time frame. In order to allow our student for longer period of time to utilize the remote lab, student can book 4 slots at same time. Okay, so not only one slot, they can book 4 slots of 1 hour at the same time. So 4 hours should be enough for one student to finish the practical exercise. So once you book and once the green bubble icon appears on your Electromeet platform browser, you can click on it, and that's how you can connect to the any remote lab in our lab.electromeet.platform. Okay, so that's the basic process that how you can connect to the remote lab. Okay, now let me go through a bit more on how I can or how you can compare your traditional experience that we have seen throughout different organizations or institute, and how we can rate our interactive learning experience by using remote labs. Okay, so let me guide you through that as well. So traditional experience means you are physically present, you are working on the equipment. You can see in this picture, you are working on concrete testing, you are working on surveying, you are working on hydraulic and pneumatic circuits. You're working on some mechanical equipment, lathe, and that is the physical experiment. So you need to be present at a time. The facility is available in EIT as well. So you need to be present at the time and working on the real equipment to do your practical and hands-on experience, right? So that is called traditional experience. Now, compared to the traditional experience, I have break down the interactive online learning experience in three different categories. Okay, the first category is recorded video. So we record the video of that particular traditional experiment performance and convert that into the interactive mode or interactive experience, experiment experience. Okay, so that is the first way of interactive learning online mode. The second one, if I can convert or possibly convert the real physical experiment or that particular exposure of the equipment into the simulated environment. So you feel like you are operating that particular equipment, but it will be in the simulated environment using the computer, using your remote lab, right? So that is the second way of interactive learning experience. And the third one, which is more interesting, that what basically we are doing, that the physical equipment we have at our EIT campus, we are connecting that particular experiment and that particular equipment via remote lab. So you can click in the remote lab and that particular equipment, you can easily able to operate and see in real time using cameras. Okay, so that is the very well organized conversion of the traditional experiment into the remotely operated experiment. So three different interactive learning mode that we offer to our students. So let's start with the first one, that how we do with the recorded video of the traditional experimental run, and then how we can convert that into the interactive experiments. So this is one of the example of the tools called H5P. So what basically we do is that when our students perform the experiments, we record the video of each and every sections of the experimental performance, okay, with multiple cameras. And then we use that video and put it into the H5P using the entire template that it will start with the aim and basic concept. So you read about what is the objectives of this particular experiment and what are the theoretical concepts behind this particular experiments. Okay, so you learn and understand that. Now we want to check that whether what you are learning throughout the basic concept. So we are asking you some questions. Okay, it's like multiple choice quiz. You can see that. And most of the case, we are making this quiz compulsory because we want to see that how our students are learning throughout the entire section. Once you attend the quiz, successfully pass the quiz, and we have different types of quiz like fill in the blanks, true, false, multiple choice types of questions. Then we move to the next part of this section that you need to see the video. Okay, now videos are divided. It's not a one long video, but we divided video in small sections, break down into small sections, and we label the video. We label the diagrams within the video accordingly that you can be able to easily understand that what are we trying to explain it to you. Okay, and once you finish that small video or three or four multiple small videos, we have drag and drop quiz again. We have multiple choice or fill in the blanks quiz again, and we can make that quiz compulsory as well to be able to check that whether you are getting enough knowledge and information from the video. So that is how we run different breakdown of the video and evaluating our students throughout this section, throughout this complete experimental exercise. And then what basically we are doing, that we are also including any software related to hydraulic circuit or related to that particular experiment. When we are asking our student um, to work on that software and develop the exactly or similar hydraulic circuit exercise using the software. So we are checking, and these are the checkpoints that we have done to evaluate our students whether they are learning it correctly on a breakdown manner. And once they develop that demo, they need to finish the assignment, they need to submit the demo, and the final submission will happen. We can either mark and give the feedback to students based on their entire submission, right? So this is how this entire exercise will work. I will show you different component of this H5P exercise. So this exercise is video and the quiz, and you will see that hydraulic circuit explained in a way that you will see this pressure gauge. And here we have shown you that how the pressurized system and what this gauge shows you, okay, in terms of reading. Then you will go to the fluid sim or any related software to do the demo. You submit the assignment with the instructions and different tasks, and we will mark you, giving you the feedback. Okay, so that is the first way of um, interactive online exercise. The second one, as I previously mentioned, that it's a simulated experiments. And what I mentioned previously, that we have converted few experiment as a simulated environment, that if you feel like you are operating that particular experiment, you are into the environment. It's like virtual and augmented reality, right? So this is what we have done with some of our exercise. And one of the best example of that exercise is electrical isolation procedures. Okay, and that is the simulated lab that I'm talking about. So you will see that you feel like you are in the room and you are isolating the circuit and going step by step in order to isolate that circuit. So you will see that, okay, here you begin the isolation simulation. Now, before you isolate the circuits, you are require some equipment to take it with you, right? So here we are asking to select you 10 items which you require for electrical isolation work, right? Now, you need to select correct 10 equipment based on your theoretical experience. And then if you can't select one, it will ask you again and again. And then once you are successfully selecting all the 10 equipment, you are going to open the cabinet to start with and switch off the isolator and switch the breaker. You are then selecting tools and you are testing that circuit is dead or not. Okay, and this all step-by-step process is happening within the simulated environment. You feel like you are there in a room isolating the circuit by selected equipment, but this is really a simulated environment. Okay, so this is one of the good example of the simulated environment. We have few more example. Now here you will see that you are going through the simulated environment of the one of the plant. That's where you will see flare systems and different types of columns, and you will see the different data in the simulated environment regarding the plant in real time. You will see how all the equipment works regarding the safety performance. And if any issues, you can monitor here in terms of critical safety performance of that particular equipment. Or you can go through that critical safety performance of each and every equipment in the simulated lab. And then Once you select everything, you will go through a virtual field operator and walk through the plant. Okay, so this is yourself, you are there, and you are walking through the plant and checking all the equipment in real time. So again, it's a simulated environment, as I mentioned to you, but you can be able to walk through the plant and see the equipment in real time.
Hi,
Okay.
Harrison. I'm just going to jump in for a sec. I'm just
Yep.
going to replace the slides on the screen because I think there might be an issue with the size of the video that's in the presentation,
Okay.
which it might be affecting. Just updating it. Just give me
Yep.
one moment. Was it this slide you were on?
Yes, correct.
Okay. You can take control now.
Yep, okay. Thank you, Riley. I'll just taking control. Yeah, all good. But when I take the control, I can see the smaller version of the slide. Is it okay?
Yes. Yeah, it looks fine.
Okay.
Yep.
Sure. So you can see that particular equipment that you have seen all the data and virtual like critical safety performance. You have seen the temperature, pressure of that particular equipment. While you walk through the plant, you can see it again in real time in this type of bubbles. You will see that bubbles, right? So it's a virtual plant, but you will see all these information related to that equipment and parameters throughout the plant. So very good example of the simulated environment of the plant, capture all the details in that particular simulation. So you feel like walking in real time around the plant, right? The third one, as I mentioned, very interesting ones. And that's where what we have done at EIT that converted our traditional experiments and using the webcams and real-time real learning experience, we have connected that particular equipment to the remote lab. And any of our students can operate that equipment remotely in real time. Okay, so let me show you that as well.
Harrison, this is the slide. I had to remove the video.
Okay, no issues. I will share my screen.
Yeah.
Because I have the slides open in my screen. So let me, yeah, let me open it up that slide and then. So guys, I'm sharing my screen here so you can see the video. Okay, I will go on the presentation mode. It's starting from the beginning. So let me see how I go to that particular slide. Let me start from here. Maybe. Can you see my slide there?
Can we ask everyone, the audience, to send us a thumbs up if you're able to see the screen right now and hear us? Thank you.
Yeah, can you see the video playing there as well or no? Marvin, can you please confirm that?
Yeah, I can see it from my end, Doc.
Okay.
Yep.
All good.
Everyone's saying that they can see it now.
Cool.
Okay.
We apologize, everyone. Apologies for the technical issue.
Thank you, Riley. So I will present that video. Before I will present that video, I will explain to you that what is that remote lab is about. So we have an equipment. It's called manufacturing process control lab. So that is mimicking the production line of any equipment or any any company or any factory, that's where you will see that one thing happening, and then remote arm or robotic arm pick up the equipment or the thing to the another one and processing on the another side. And at finally, after all the stages of the process, it will put that into the warehouse as a packaging side. Okay, so this particular remote lab. We have converted this equipment into the remotely controlled equipment. Okay, and this video will tell you more about that remotely controlled lab.
Hi, Harrison, are you there?
Yep.
Would you be able to just try resharing, and when you reshare, just switch that toggle include sound when you reshare your screen, if possible.
Let me see how. So let me stop sharing now, and then I will reshare again. Yes, share and include sounds. Yeah, correct. Okay, got it. Okay, do you want me to repeat the entire video again, or are you okay with starting it from now?
Maybe we should restart it.
Okay, okay.
And can you put the slides into presentation mode by any chance?
Okay,
If
let
you'd
me
start from the
see.
current slide.
It just says present live or start from the beginning. That is the option.
If you just click that one next to the drop down, that should
Where I have these four options.
Harrison,
next to the drop down arrow, or down the bottom of the
Yeah.
screen next to the zoom.
Oh yes, yes, yes. Got
one?
it, got it. Yeah, yeah.
Yeah.
That one. Okay. So I will repeat the video again. Hopefully now everyone hear the sound as well. It might take a bit of time, but hopefully it will be coming to the. Yep. Okay, so I will start the video.
Hello everyone, my name is Felix. Today,
Can everyone listen to the video now? Hear the audio?
All good.
Yep, audio. Yep. Okay. I think it's coming to the next slide somehow. Let me go back.
Hello everyone, my name is Felix. Today, I will be showing you a manufacturing process control lab developed for EIT as a remote lab project. The automation workbench depicts a typical industrial workflow process in any of the industries. It comprises of 8 stations, with each individual station having a Siemens PLC that is controlled by a ladder logic program using Siemens portal and the pneumatic system for the robotic parts and movements. The system is configured with a start button, with start, stop, reset, and emergency buttons. The main aim of this project is to ensure that the automation workbench can be accessed remotely by online students. Here is the first station. The first station is actually the turntable, which contains the load to be fed onto the machine. And we have the robotic arm on station 2, which actually picks the load from station 1 and transports it over to station 3, like we're seeing currently. And in station 3, we have some engineering processes going on. You can likely see, like during operation. And we have robotic arm in the next station, station 4, which picks the already fine-tuned load and transport it down to station 5. But station 4 has the ability to detect a good quality product. It either rejects or sends further to station 5, which is being transported by conveyor belts. And the robotic arm of station 7 picks the fine load, take it over to station 6, where another little load is fitted into it, and it picks it up and finally transport it down to station 8, which is for storage. Right now, I'm going to show you how the
I don't know, it might be loading or something or buffering. Okay, but basically this is yeah, Riley, if you wanna.
Yeah, no, I'm not sure, Harrison. Sorry.
That's okay. So let me explain. I think the important part of the video being shown. So this is the ladder logic. So the student, one of the student that you hear explaining you guys is that showing you that how the ladder logic program works station by station. And in the next slide, if you see that this is the graphical user interface that our student created, and this is where you can connect that particular production line system remotely. So you might see that here as well. So the audio will come after having this subtitles. So you will see that we have 3 different options of matching color, inverting color, always black, always white, and then you can select the number of loop that you want to go with. And you can see on your right hand side that all number of stations, all the informations are provided in the each and every station, that how it works, particularly each stations how it works. And then once you press the start button in the graphical user interface connected to the remote lab, and that's where you will see in your camera that the production line training system will operate in real time. Okay, so after these explanations and the subtitle, now you will see that. So you select the number of loop, you select match color or invert color, always white, always black, whatever the option you like to select, and press play. And that's where you will see that particular production line training system will operate in real time remotely. Okay. And you will see with the use of camera connected to the production line training system, each and every stations, that how it is performing the operations that you have given the control, you have given the command in station by station. Okay, and that's how you will operate this equipment remotely. And that is one of the good example of remotely controlled experiments, and it's connected to the remote lab. So you can book the remote lab, you can use that equipment in real time. Okay, let's just video finish it and then we can talk later. So you see the final product, it's inverted color, right? So that's how you can select it. Let me stop sharing my screen and I'm in mode. Can I have my presentation back, or do you want me to start presenting from the slide that I have?
I think there were less issues when you were sharing your screen, Harrison. So
Okay.
maybe we'll just
Okay.
stick with that. Yeah.
Sure. Sure. Okay, so I will start sharing the screen again then. Okay. Hopefully you can see my screen or not yet. No.
Not yet, Harisinh.
Not
Okay.
yet.
Give
Yeah,
me
I can see it now.
5
it's
seconds.
it's
Yep.
loading.
No.
Loading
It's
now.
loading. Okay. Hope you can see my screen, right?
Yep, perfect.
Okay.
Yes.
Thank you. So as I mentioned to you all about 3 different ways how we can provide a practical exposures to a student. Let me wrap that up in 3 ways. So the first one is recording the video, making the video interactive enough, putting the evaluation like the quiz or filling the blanks type of question to see whether our students are learning and having the information from the video and the information from the concepts. And then we can ask our students to provide the simulations and the assignment task and submission to give them a proper feedback on that particular video exercise using H5P. The second one that I have discussed is the simulated experiments, right? The simulated experiment is the one such as electrical isolation procedures, when you can walk through the virtual field operators. So that is one more exercise that you can do. And the third one, you can see that production line system connected via graphical user interface. You can select number of loops. You can select what type of process you want to perform. Like you want to always select black dyes or white dyes or inverted colors. You can easily select that and operate that experiment. You can definitely log into TIA portal, change the program accordingly, or troubleshoot the program on real-time basis, right? So this is the kind of active collaborations and learning throughout our process. A few more examples that we have apart from production training line system. We have a VFD motor controlled via PLC, and that is connected to a remote lab. So you can easily change the program. You can troubleshoot the VFD and see in real time with camera connected to it. We have the simulated experiments of induction motor, cage induction motor, and that's where you can see cage induction motor simulated in the remote lab, electronic platform. Okay. Apart from the remote lab and the three different ways to have the interactive learning experience, we have hands-on workshops and work integrated learning as well. So hands-on workshop, we have um, 4 different types of workshops. So, and these workshops are face-to-face on campus. So those who are studying online, they need to come face-to-face for 4 weeks, full time, and attend these workshops. So workshop will run in a way that the first week is measurement science workshop, common for all disciplines. Second week is breakdown into two. So BCS, civil engineers and mechanical engineer students are going to one workshop, and the second workshop is for the electrical and industrial automation students. Week 3 will be again further breakdown into civil engineering students doing different experiments related to concrete testings and surveying. Electrical engineering students and industrial automation students are doing separate experiments, and mechanical engineering students are doing separate experiment as well. Okay, so that's how we have 4 weeks of workshops face to face. As you can see, different photos, students performing different exercise throughout the workshop. The work integrated learning is one more thing that you are required to attend 240 hours of um, industrial experience. And that comes to the picture that EIT provides you and connect you to the industry representatives, and that's where you can start your journey to going to the industry, learn how industry works. You can work for 240 hours, so somewhere around 3-4 months, and learn about the industrial operations as well. So that is work integrated learning. Now, as I mentioned to you, you will have exposure to real working environment in your own engineering field. You can try something new given the project of the supervisor, and you um, finish the project and impress them, and they might offer you a full-time job there. That is a very good chance to absorb yourself into the industrial and industry ready or job ready type of stuff. You have the opportunity to showcase your talent, commitment, and value, and that's how you can get your enhanced CV and probably relevant experience and going further into the job opportunity as well. Okay, so coming back to the zero credit unit, which I just mentioned about BXX 001 to 004 hands-on workshop, MXX 001 for master's students, and MXX 510, which is the industrial experience for masters, and BSc 110 and 210 is for bachelor students. Studying at EIT, so as I mentioned in the beginning of the sessions, that we offer a full range of courses starting from professional certificate to Doctor of Engineering. You can see that professional certificate on the top, diploma, advanced diploma, undergraduate certificate. Those are the 6 to 12 months courses. Professional certificate is only 3 months course, and then you can go through Bachelor of Science, which is 3 years full-time or equivalent, and then Master of Engineering is 2 years, and we also offers Doctor of Engineering for 3 more years to make yourself expert in the field. Delivery is online and on campus. We have live and interactive tutorials through webinars. We have industry expert lectures. So as Marvin mentioned, we have a huge pool of industry expert lecture around the world. Those we will be teaching you online and providing you enough support for technical side. And you have seen throughout the session that what the practical learning experience, facilities, and resources available on our physical laboratories during the workshops, during your work integrated learning trainings, virtual laboratories and remote laboratories, and simulation software to see it. So thank you very much for your attention throughout the presentation. So sorry about few
Yep. Thank you so
issues
much.
within the presentation? Do you have any questions? And I'm handing over to Marvin
Yeah,
now.
thank
Thank
you
you very
so
much.
much. Thank you, Dr. Harrison. So, yep, we would like to apologize again for the issues a while ago, but we were able to continue and then proceed with our goal of sharing this information with you guys. So, yep, now for the Q&A section, we'll be allowing you guys to send us questions that will be answered by Dr. Harrison. And Doctor, we have two questions already on hand right now. The first question would be, if one doesn't have experience for required software using remote labs and required trainings, is there a training or tutorial offering to learn these various softwares that are accessible? So that is actually one of our attendees here today.
Yes, so let me give you an example. When we ask our students to use any software, we we kind of know that obviously we need to give them a kind of what you can call the kickstart type of course. So we will provide the instructions manual of the course of the particular software, that okay, this is how you can download the software, or if it's available on our remote lab, you can use it through remote lab. Step by step process of explaining the graphical user interface of the software, and then we will going to the more complex environment of the assessment, and then how you resolve that or solve that assessment using the instructions and using the software graphical user interface. So we will provide all the informations related to software in the assessment. We will sometimes what we will do, we will record few videos and provide that video recordings to our students to understand the graphical user interface of the software. More um, importantly, if still you some of our students have any issues with the software and remote lab, they can contact their lecturers and they will have consultation session with them to go through the software exercise and providing you the enough support on that particular software, even if you don't know the software. Yeah.
All right. So yeah, I can actually see now that's coming from Ramesh Pillai. Okay. Thank you so much for that question, Ramesh. I hope it was Dr. Harrison was able to answer your question. And we have second one, Doctor. This is from 2024108244. He was actually asking, how do I know which labs corresponds with my modules? So, for example, the IT MA
Yeah.
601, Physical Media and Industrial Data Communication, the
Okay.
IT MA 602.
Yep. Got it. So when you are talking about any DIT 17 or MA 601 physical media unit or
Mhm.
module, um, you have a practical assessment document. Okay. Now within the practical assessment document, it will tell you about which software to use. So when you go to the remote lab, you search for that particular software, and that's where the list will come up that, okay, let's say, for example, MATLAB. Okay. So if you type the MATLAB in the search button, you will see that how many remote labs you have a MATLAB. Then you need to check that, okay, which lab is available to book now. If you book the lab and access the lab, you will definitely see the MATLAB software in that particular remote lab. Okay. If you don't book that one, or if it's fully booked, you can go to the next remote lab and book it, that particular remote lab to use the MATLAB. So this is how you know through the assessment document that which software you are required to use to solve that particular practical assessment. And accordingly, you need to search on our electronic platform that which software you are required, and it will give you the list of labs with the software.
Right. Thank you so much, Doctor. Yeah, we have one last question here. I don't know if it's, but can I have access to the demo video presentation on how to use MATLAB and Simulink?
So MATLAB and Simulink, if
Yep.
you are a EIT student,
Mm,
we have campus-wide license of MATLAB. And Simulink is within the tool in the MATLAB. So
mm,
definitely when you have MATLAB campus-wide license, you
mm,
can download that particular software, entire MATLAB in your own computer.
mm.
Okay. If you want to use MATLAB and Simulink online, it, the feature is available on MATLAB website. through EIT campus-wide license using EIT email address. Okay. And that's where you have that demo or video presentation of anything that is related to MATLAB and Simulink. So it is
All right.
not available to anyone, but as we have the campus-wide license, we can
Yes.
provide that demo video presentation to our EIT students.
Yep. So the best thing that you should do is inquire with our courses, and then we will walk you through the process as well. And of course, with this one. All right. Okay. I think that would be the last question that we have for today, Dr. Harrison. Thank you so much for your time. If you have any questions, though, please feel free to reach us. I have posted the email address wherein you can actually send all your questions, and we'd be happy to answer that one for you together with Dr. Harrison. Okay, thank you so much. And I think that's it for today. Thank you. Thank you everyone for attending for today's virtual open week, day 2, insights on our remote labs and simulation softwares. Thank you so much and have a great day. See ya.
Thank you very much all. Thank you.
Thank you.
Bye-bye.